Hello, pre-algebra students. This video is going to be on independent and dependent variables. To help us get started on today's topic, we've got this warm-up question here. This is going to be the starting question we look at when we get into some of the examples. Go ahead and pause the video now to read through this warm-up question and then choose which equation would represent this situation, A, B, C, or D. Come back to the video once you think you've got an answer. All right, so for this question here, we have Marcus reads 30 minutes each day, and we're told D is going to represent the number of days he's reading, and that variable T is going to represent the total number of minutes he reads. We are looking for which of these equations here would describe the situation. When we're talking about 30 minutes each day, in order for me to figure out the total number of minutes he reads, it's going to involve some multiplication. Specifically, I would be multiplying those 30 minutes, those 30 minutes times the number of days he reads. So for example, if he reads 4 days, I would want to multiply that 30 minutes per day times those 4 days. That would end up giving me that total time he's read. So all I've got to do here, if I switch out those words I was using with those variables, I'm looking for 30 times the number of days, and we're told we're going to use D to represent the number of days, would equal that total number of minutes he's read, and we're told T over here represents the total number of minutes. So we get 30D equals T. Equations C and D are wrong because they've got addition in here, and you wouldn't be adding 30 minutes plus the number of days or 30 minutes plus the total number of minutes. There wouldn't be any addition there. So we're left with these two over here. And if we pay attention to the place we've got those variables, we see that B would be correct. A is close because A's got that multiplication we're looking for, but you would not be multiplying 30 times the total number of minutes. You'd be multiplying 30, like we said, with the number of days. This right here comes from our lesson from Unit 2 on being able to look at story problems and represent them using an equation. And one of the things I want to point out here with this equation we ended up writing is there's two variables in it, because the only thing we knew was how many minutes he's reading each day, but we didn't know how many days. And because we don't know how many days, we're not going to be able to know how many total minutes he read. This unit that we're about to get started on today is going to be looking at a lot of these situations here that have two variables, like this problem right here. And we're going to be building on what we already know about situations like these. To start us off today, what we are going to be doing is the following things. We're going to first talk about being able to identify independent and dependent variables. So that's going to be the first focus of this lesson. Now you know what variables are. It's those letters, specifically D and T in this problem up here. But one of those we call the independent variable, and the other one we call the dependent variable. So we'll talk about what those are in just a moment. And then after we learn about independent and dependent variables, we're going to see how you can use those to help create tables and create graphs from situations. We've created a few tables here and there in this lesson, but this unit in particular is really going to rely on a lot of tables and graphs to help us understand situations. So that is the plan for this lesson video. To get us started, we said that first thing we're going to be looking at is talking about how you can identify what an independent and what a dependent variable is. So I'm bringing back that same problem from above. We're going to still look at this story about Marcus. And just a reminder, earlier we said Marcus is reading 30 minutes each night. He wrote the equation T equals 30D to represent the total amount of time that he has spent reading. And so that was that equation we had chosen above. We've mentioned already in this equation there are two variables, and one of those variables we call the independent variable, and the other one we call the dependent variable. And so to help us figure out which one is which, I've got a definition over here that we're going to use. The first part says the independent variable changes, and when it does, it affects the dependent variable. So with that, we're talking about when one thing changes, it's going to affect or impact the other one. It kind of makes me think of like cause and effect. So we can think of that independent variable as like the cause or the initial thing, the starting point, and the dependent variable is what gets impacted. It's the effect. Another way you can think of it is actually using the word depends. I'm noticing there's independent and dependent variable. We can use this phrase depends on to help us figure it out as well. The dependent variable is called a dependent variable because the dependent variable is the one that depends on the other. So we can say the dependent variable depends on the independent variable. And using that phrase depends on is for a lot of students how they successfully are able to identify which one is independent and which one is dependent. So in this story, remember we had two variables. We said that T represented the total minutes Marcus reads. And then that other variable, the D, represented the number of days he reads. So to help us figure out which one is independent and which one is dependent, it can help to use that phrase depends on and think about which order would you want to put these two phrases. So kind of like filling in those blanks there. Would we want to say the total minutes he reads is going to depend on how many days he reads? Or would we say how many days he reads depends on the total minutes he reads? Go ahead, pause the video and see if you can figure out which order would I want to fill in those variables into these blanks here. The sentence that is going to make the most sense here is that the total minutes he reads, that total minutes he's going to read is going to depend on the number of days he reads. We had talked about like cause and effect here. You can think of it that way too, is the impact is that total number of minutes read. That's the effect of how many days he chooses to read. So if I match up this sentence right here we wrote to this phrase, we see that this first one here is going to be our dependent variable, because our dependent variable is the one that depends. The dependent variable depends on the independent variable. So for this situation right here, if I wanted to identify which of these is independent and which one is dependent, that total number of minutes read is our dependent variable. And notice I'm shortening dependent to DEP for right now, just so I'm not writing all day long. And then that other one, the number of days he reads, is our independent variable. Again, if you think about it with like cause and effect, the starting point, the thing we would be changing is how many days he reads. And if you change how many days he reads, that's going to be what affects the total minutes he reads. Kind of like our cause and effect again. I keep switching between depends on and the idea of cause and effect because different people find success thinking about it in different ways. So see which way makes more sense to you and just stick with that. We had mentioned one of our goals in this lesson, though, is that we're able to identify independent and dependent variables. And so however you think of it, we want to get to this conclusion here, that the number of days is the independent variable and the total minutes is our dependent variable. Knowing which one is independent and which one is dependent is going to help us with our second goal for today, which is using independent and dependent variables to create tables and to create graphs. So the next part of this is going to be jumping into the first table we create. The question here says, create a table to show how many minutes he has read in the first 7 days. Now, when I go to set up my table, there's 2 variables here. So that means there's going to be 2 columns that I'm talking about. And when you create a table, there's a standard way we create the table. When we go to create our table, this first column right here is always going to be your independent variable. So over here in this box, it says when you create a table, the independent variable should be in the first column. And then naturally, you can guess what's going to go in that other blank. The second column is going to be our dependent variable. That is because we had said earlier that dependent variable is going to depend on the independent variable. It's like the effect, and the independent variable is the cause. So we want to start with the independent variable. Oops, I don't want to write independent there. But we want to start with that independent variable because that's what I'm going to need to know first. And then once I know the independent variable, I'll be able to figure out the dependent variable. That makes a lot more sense when we're looking at a specific example. So let me show you using this example about Marcus and his reading books every day. So up here in the first part, we said that the independent variable is the number of days and the dependent variable is the total number of minutes. So that means in my first column is that independent variable. We said that was going to be the number of days. And then the second column, our dependent variable, would be the total minutes he ends up reading. Notice if I go to fill out this table, it's a lot easier for me to start over here with days. I know he reads 30 minutes per day. So it's a lot easier for me to say, well, maybe he starts off reading 1 day. No, maybe he changes that and decides to go up to 2 days. No, he's going to read 3 days. That's the thing he can change. And when he changes the number of days, that impacts the total minutes he's reading. It would be a lot harder for me to start over here in that total minutes column and then work backwards to figure out the number of days. So the question specifically said, we're going to create a table to show how many minutes he has read in the first 7 days. So over here in my first column, or that independent variable column for days, I'm going to number 1, 2, 3, 4, 5, 6, 7 days. And then using that information, we can figure out how many total minutes he's read, using the number of days along with what we were told in the story about how he reads 30 minutes per day. Again, go ahead, try to pause the video now and see if you can fill in the remaining missing numbers in this table. All right, how'd you do? Well, using this information here that he reads 30 minutes per day, after 1 day, he has read 30 minutes. If he's reading 30 minutes each day, after 2 days, he's read another 30 minutes, which would be a total of 60. After 3 days, he's read another 30 minutes, which would be a total of 90. As you fill in this table, you can either notice that each time we go up a day, the total minutes is going up 30 minutes, or you can notice this relationship between the days and the total minutes. Remember, we wrote an equation earlier, and that equation looks like this. It had multiplication. So you could either use that pattern of we're adding 30 each time, or you could use that multiplication there. We're just multiplying 30 minutes times the number of days. So for that next row in my table, I could multiply 4 days with 30 minutes and get 120 minutes. The remaining values in the table would look something like this, where that last row of 7 days, he would read a total of 210 minutes. Notice I started my table with 1 day. There's an extra row we could have put at the top of this table. If he read 0 days, how many minutes would he have read? Well, if he reads 0 days, that means he didn't read at all. So he read 0 minutes. You could figure that out just using what you know about life. And if you don't read, that means you read 0 minutes. Or you could, again, use that equation we were talking about earlier. If I take the 30 times the number of days, I get the total minutes read, and 30 times 0 is 0. So this right here is where we're going to pause for this first problem. In this problem, remember, we covered two major things. We covered being able to identify independent and dependent variables. You can either think of that as like a cause and effect, where the cause is the thing that you change and the effect is the thing that gets impacted when you change. Or you can use this phrase depends on. We were able to figure out that the total number of minutes he reads is the dependent variable because the total minutes he reads depends on how many days he chooses to read. Once you know your independent and dependent variable, we can use that to create tables. And the key thing about creating tables is that first column we said is always going to be your independent variable. And then the second column is your dependent variable. That's going to also be true if you set up your table sideways. So less commonly, but still definitely possible, you can see tables set up like this, where it goes sideways instead of up and down. Just like we did up here, days would be listed first in our table. Our independent variable would go first, and then the total minutes would go down here. It would have the exact same information that we had in our table. 1 day is a total of 30 minutes. 2 days is a total of 60 minutes, and so on. To give you an opportunity to practice everything we've learned so far, I'm going to scroll us down to our second example. In the second example, we're also going to be talking about graphs. But the first part of this is super similar to what we had just done above with that story about Marcus and reading books at night. In this example here, we've got Talani makes $8 per hour at her job. Let H be the number of hours Talani works, and T be the total amount of money she makes. The equation T equals 8H can be used to calculate the amount of money she makes when the number of hours she works is known. Just like we did above, there's two things I'm looking for in this first part. The first is, can you determine which one is the independent variable and which one is the dependent variable in this situation? Notice we're already given the variables. I know H is a variable and T is a variable, so it's just a matter of deciding which one is independent and which one's dependent. And then the other part is making a table to represent the situation here. Go ahead, pause the video because it's a great way for you to check and see where you're at on this topic and how you're doing. And then once you've thought through it, you've come up with some answers, come back to the video and see how you did. And we're back. So that first question you were thinking through was, which of these is the independent variable and which one is the dependent variable? I think I mentioned above, for me, I really like thinking about what depends on what and filling in those blanks in my head. If you've ever had a job, you know which one's going to depend on which. I'm going to be able to figure out, if I'm trying to fill in this statement from this problem, that total money she makes is going to depend on how many hours she's working. If you're thinking about it with like that cause and effect idea, what comes first? Well, what's going to come first is her working those hours, because her working a different amount of hours is going to impact, it's going to change that total amount of money she ends up making that week. However you think about it with the cause and the effect, or the what depends on what, that's going to help us figure out that the total money she makes, if that's what depends on the hours, the total money she makes, that is our dependent variable. And then the hours she works is the independent variable. Remember, your independent variable is like what you're starting with. So she's going to change how many hours she works. And if she does, that impacts how much money she makes. So for this first part here, what we're looking for is maybe you just saying that the total amount of money she makes is our dependent variable. And I could say number of hours she works is our independent independent variable. So something like that would be a great answer. And if I asked you, how do you know? You know I love asking that question. You could literally say this right here, what we've already got on the screen. I know that because the total amount of money she makes is going to depend on how many hours she works. Now, being able to figure this out is going to impact our second question, which is making a table. When you went to set up your table, how did you set up your table? What did you put in that first column? Well, above, remember we said that first column needs to be our independent variable. That's going to be the number of hours she works. If you hadn't figured out that first part and you just jumped to the table, maybe instinctually you were thinking, okay, I would want to start my table with the number of hours and use that to help me calculate the total money. That's a great way to figure out your independent and dependent variable too. So when I go to create my table, I've got that first column, remember, is going to be our hours. And then that second column is going to be the total money. So if we go to start filling out our table, maybe we'll start this the same way we started the one above. If she works 0 hours, well, if you don't work, it means you make no money. So we get that first pair of numbers in our table is going to be 0, 0. And you could always fill in a couple other values. For this part, it didn't tell me any particular number to count to in my table. So maybe we just do like the first 5 hours, although she's probably working more than 5 hours, maybe not. But 1 hour would be $8, 2 hours, $16. Remember, I'm just using what we were told above where she makes $8 per hour. And the remaining numbers in that table would be 24, 32, and 40. Again, you could figure out those other values just by noticing each time she works another hour, that total money is going up by 8. Or you can notice that each time we're multiplying the number of hours, 5 times the $8 per hour to get that 40 total dollars that she makes. Either of these are going to get you to the same values. So this was the first part, is we've got an independent and dependent variable. We've got a table. One of the other goals we're going to be working on throughout this last unit is being able to graph situations. It's been a moment since we saw some graphs. I know we had looked at them back in developmental math where we talked about plotting points on a graph. But our goal for this unit, now that we're in pre-algebra, changes a little bit, where our goal is we're actually going to be graphing entire situations and using lines to graph the situations. And a big piece to being able to do that is knowing your independent and dependent variable and being able to make tables and seeing how tables help you graph situations. So to talk through that last piece of today's lesson, we're going to use this story here to make a graph. So I've presented us over here with a little grid for us to use for our graph. And one of the first things we're going to need in order to graph this situation is to include the x and the y axis. If you recall from developmental math, the x-axis is the name of that one that goes sideways or horizontally on our graph, and your y-axis is that one that goes up and down. So lots of times you'll see like an x and a y there. Now the way I drew it up here, we've got our positive numbers over on this side and negative numbers over on this side. Positive numbers that go above that, the intersection point in the middle, and then negative numbers down here. But in this situation and looking at my table, I'm noticing I'm not using any negative numbers here. Everything is positive. So when I go to graph this, I'm not going to need all 4 areas of the graph. We call those quadrants. All I'm going to need is that one little positive section. So instead, my graph might look more like this, where I'm just using that positive area here. Now don't worry, before we get to the end of this unit, we'll definitely look at some situations with negative numbers, but for right now, we're going to keep everything positive. So one of the first things I'm going to do to this grid I've got over here is let me draw in that x and that y axis. So down here, this could be my x-axis, and then coming up here, we've got my y-axis. Now, because this represents a story, one of the things I'm going to want to do is label the X and the Y axis on this graph. Similar to how when we created our table, we started off by labeling those two columns, hours and total. And just like there was a standard way to set up our table where we said that independent variable is first in the table and the dependent variable is second, the same thing is true for our graphs. When we graph, our independent variable always goes down here on your x-axis, and our dependent variable always goes over here on your y-axis. So in this situation, my independent variable, remember we did it from the beginning, independent variable is the number of hours she works. That means down here, that green line that I drew, I would want to label that. Let me erase my independent variable. I want to label that as the number of hours worked. And then over here, my y-axis will be our dependent variable, which in this story was that total money she made. So I want to, I don't think I can, oh, maybe I can. Total money made. That's not bad writing sideways. The other thing we're going to need in order to represent this situation is I'm going to need some numbers here. So if I look at my table, it's going to give me an idea of what numbers I want. When we look at the number of hours worked in my table, I notice I'm going from 0 to 5. When you go to label these numbers on your graph, you always want to count consistently. This corner right here, where the x and the y-axis cross, that is always, always, always 0. And then whatever I choose to count by, it has to stay consistent. So what I mean by that is I can't go 1, 2, 3, 20, 100, because I'm not adding the same amount each time. But I could go 0, 1, 2, 3, 4, 5. There, I'm just adding 1 each time. When I go to label my y-axis with the total money made, here, if I try to count up by 1 as well, I'm going to hit a problem because thinking about this situation and the numbers I have in my table, notice they're a lot bigger because she's making $8 each hour. So I'm going to have to count by a bigger number. The same thing is true that we said earlier. We've got to be consistent in what number we're counting up by. So maybe we would want to count up by something like 10. We could do 10, 20, 30. Sometimes when I teach this in class, I get that 10. And that's perfect. You could do that. However, there might be a number we could use that makes it a little easier. If I look at my table, I notice that our table is going up by 8 each time. So I could make my life really easy by just making each of these lines count as 8. You could do 10, 100%. That's totally okay. But it means if I wanted to find the number 8 on this graph, I would have to estimate. 8 would maybe be like right there. But if we count by 8, it means I don't have to estimate anything. If I want to find the number 8, it's right there at that line. So my y-axis, let me do that just to make it easier for us. And I'm going to have that one go up by 8. Now that I've gone ahead and I've set up my graph, making sure that I've got my independent variable on my horizontal axis, that x-axis, and that I've got my dependent variable on my y-axis, now it is all ready to graph. The way we graph this is we can use either the information we were given, or since we created this table, we could use the table. When you're graphing points, remember any point on this graph is going to represent 2 pieces of information, 2 numbers. For example, if I pick this point right here, that point would represent Talani working 2 hours and making $40. So notice there's 2 pieces of information we get from each point on this graph. Now I'm going to erase that because that wasn't true based on this story. What was true, if I look at our table, is that if she works 0 hours, she gets $0. So that means there's going to be a point right here. If she works 1 hour, she makes $8. So I could go over to my 1 hour and then up to $8. And then I can continue that. 2 hours would be $16. So I'm just going up another $8 after she works another hour, and so on. So we'll go up another $8 to $24 and over to 3 hours. And we'll end up getting all of these points here. You, of course, could also just use the information in the story that she makes $8 an hour and get those same exact points. One of the things we had mentioned in this unit is we're not just plotting points anymore, we're graphing lines. So to finish this off, something you can see is I'm going to draw a line through these points to represent this situation. When you're working a job, of course you could work 1, 2, 3, 4, 5 hours, but maybe you work 1.5 hours. You would be paid an amount of money for that as well. So that line there is to help us see that all of these points are possibilities, not just the 1, 2, 3, 4, and 5 hours. I also drew an arrow at the end because my graph stops at 5, but that's not the end of all the possibilities for her, right? She could work more than 5 hours, and if she did, she'd make even more money. Now I'm curious if we did want to continue this graph. The last point I put was here at 5 hours and $40. Where would my next point be? Well, I can kind of see because there's still a little more room on the graph, right? That 6 hours would be up here at $48. That makes sense. She's making $8 an hour. So 6 hours times $8 per hour is $48. What about 7 hours? Now, there's definitely no more room on this graph, but where would I need to go to get to 7 hours? Well, one of the things you might notice is each time to get to that next point, we were just going up $8 and over 1 more hour. So I'm going to put in a dollar sign there. Each time we were going up another $8 if she worked another hour. Up another $8 if she worked another hour. Up another $8 if she worked another hour. So if I did want to continue this graph, it would just be me going up another $8 if she worked another hour. So that next point there would be at 48 plus 8, which is $56 if she worked another hour. So a total of 7 hours. Notice those little arrows I'm drawing kind of makes it look like a staircase. That is going to be a concept we are building on in the next lesson. So I wanted to get you started thinking about that now to help you out with what we're doing tomorrow. For now, this was the last thing we wanted to learn in this lesson. So just as a summary for us, one of the things we learned is what independent and dependent variables are. Remember, you can always use that phrase, what depends on what, to help you figure those out. We talked about creating tables. When you're creating your tables, remember that first column is your independent variable and the second column is your dependent variable. And then finally, we talked about graphing. When we set up our graphs, you want that x-axis to be your independent variable and your y-axis to be your dependent variable. And you can use the information in the story or your table to help you figure out where these points are here. We are going to continue our conversation about these graphs tomorrow in that next lesson for this unit. Thanks so much for watching. Hope you have a great day. Bye, guys.